video, I'm going to look at the simulation of a diode transistor logic circuit that I got from The Art of Electronics by Horowitz and Hill. All right, so this is going to end up to be a logic circuit. So we're interested in high and low inputs and then the output. And the output of interest is the voltage across that lower transistor with the label Q3. Okay. This on, and right now my A and my B are connected to ground, so I have a low input, and my overall voltage over here is 4.425, and I'm going to say that that is high, or I might just say a 1, and then I just to sort of think a little bit of the circuit, I'm asking whether the various transistors are on or off, whether they're conducting, I'll say they're, if they're conducting, I'll say they're on, and they should then have a low resistance. If they have, there are no currents going through them or little currents going through them, they will have a high resistance, and I'll call that off. And so I'm using an ammeter into the base here, and we see our currents are for Q1, it's in the nanoamp, very small, we'll call it off, picoamp, even smaller, 0 here. So I'm going to say off, off, off. Now, in the next row, I want to look at A low and B high. So I'm going to flip the B switch. And so I flip the B switch, the switch is now high, I'm still simulating, and this current has adjusted a bit, but it's still quite low. So these currents, this current I at least caught moving. I don't remember if this one moved or not, but it's pico, so it's still pretty small. This is still 0, so it's still sort of off, and 4.425, so not much has changed. So off, and 4.425. And that is high. Now I want B to be low and A to be high. So I'm going to switch B, get in the circuit, and change B and then change A. So now A is high, and there's a symmetry between A and B. So we expect for the most part, the same results here. Very small current, no current so not surprisingly, this is the same as the row above. And then our last input will be high and high. So I'm going to flip switch B high. Now I have a high input, A is high, B is high. Now, transistor 1, I have milliamp. That is a pretty respectable current. And Q3 is definitely on. And this voltage over here is quite low, 0.02, and that is definitely low. And then now I'm left with this one up here. No, I'm in the micro. So milli, I would definitely say is on, and pico definitely off. This one I'm not as clear on, and we'll just say it doesn't matter. The whole purpose of this arrangement here with the two transistors stacked like they are here is to really firm up the state of the lower one. Doesn't matter if, if the higher one is perhaps not as firmly on or off as we might like. Its job is to make sure that the lower one is. I'm just going to say question mark. Now the next question comes is like, then if this is to be a logic circuit, then what logic circuit is it? So if we just think of this as a, 0, 0 produces a 1, 0, 1 produces a 1, 1, 0 produces a 1, and 1, 1 produces a 0. Then this is a NAND. Just think of, let's think about the opposite of this output, low, 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 high. We could identify that very quickly as an AND gate, only high. So if we had the opposite of this, low, low, high, we could identify this as an AND gate only when the two inputs are high do we get high. This is the opposite of it, making this a NAND. So we have a diode transistor NAND, and it's complicated, but you could see that these outputs of these transistor of interest were, quite high and quite low, and so it's very sort of all this complication made it sort of fairly stable. That there's for the things we're interested in, no real in-between problems. We're very clearly high and steady, or very clearly low. Okay, that's what I wanted to show you. Thanks for your attention.